Thanks. Good morning, guys. I'm Mahalakshmi. I work for the GE Global Research. I work in the Prognostic Systems Lab. My company is in Whitefield. I would basically be talking about the wireless sensor network, followed by Amulya, who would be talking to you about the ad hoc network. So after the presentation, please feel free to ask me any questions. So what I'll do is I'll begin with the first session on the wireless sensor network. So basically, just to give you a quick introduction, what we're talking about wireless sensor network is basically a set of nodes which are basically distributed spatially, and they're communicating to each other wirelessly. But if you take each of these nodes, they are essentially it's nothing but where you have a radio, you have a microcontroller, you have an associated electronics, and it could have an external or an internal sensor, an embedded sensor, or you could have a sensor connected externally. You could have the circuit outside. So this essentially constitutes a node. So all of these nodes, when they are spatially distributed, they're communicating to each other. At the same time, they're also talking to one central system where they are transferring the data. So when I talk about sensors, I'm not sure how many of you people are aware. These sensors could, if you want to deploy a sensor on a motor, you could use the vibration that you're getting out of a motor, for example, and how much of this energy from the vibration you can harvest to power these sensors. So there are different kinds of enablers to get these. So because we want to make these nodes as small as possible, as simple as possible. So we're trying to make use of what is available for us to power these nodes and keep it active. So as an example, as I told you, in a power plant environment, so some of you may know you have a gas turbine in a power plant. If you have visited, or if you've seen or known about them or read, you have a gas turbine. The exhaust of the gas turbine drives a steam turbine, and all of this together drives a generator from which you get power to your houses. So to this, in this kind of an environment, right? So what they typically do is, so a company like GE, where it manufactures gas turbine, steam turbines, and the generators, it would, even before it hand it over to the customer, you kind of commission the plant and say, okay, this is the kind of efficiency you will get out of running a power plant, right? So before you do that, we have performance engineers who would go to the site, who would deploy these sensors, and I'm talking about wire sensors in this case. They would take roughly about 3 to 4 days, and it takes a lot of time and effort to get these guys in one place, run these sensors into different locations, and sometimes they are harsh environment. You'll have chemicals, you'll have vibrations, and running these cables to those kind of locations is really tough. So that's the kind of environment we have, and we have testing that is performed. And at the end of the testing, what you basically tell the customer is, look, this is your net heat rate. This is your total performance that you get out of a power plant based on the equipments that we have installed. And if there's any opportunity for us to make any performance changes, that is the time. So the testing itself is really critical. But as a thought, what we use this as an opportunity to demonstrate how the wireless sensors could be useful for this application. And what we basically did was, okay, so we took a so that's typically what they do in a power plant testing. So the challenge here is to maintain the precision. So in order to be able to give them accurate efficiency to the customer, you need to have sensors that are really accurate, precision wise, to give them and the availability of this data. So when you're continuously acquiring this data, since it's a short period of time, you need to ensure that this data is available throughout those particular duration of which you perform the test. And then you would go back, you sit and analyze, you look at how the flow corresponds with the temperature, the pressure, and a whole lot of stuff, which is essentially done by people who are more knowledgeable on the domain side, on the gas turbine or the steam turbine, for example. Now, how a wireless sensor network could be an advantage for this kind of an application? Like I said, right? So you would spend time in wiring these sensors, and there's a time is money, and then you have problems of wiring them and into these. So if I could actually reduce the entire cycle time, so if it is 5 days, right? If I could reduce to 2 days, just have these guys come there, just deploy the sensors and start collecting the data. And of course, there needs to be a lot of planning done before and where and how I install these sensors, but you know the locations. So how easy, how much of a saving would I have if I have to use these sensors? And if you know some of the wireless sensors are cheap, right? The radios these days, well, they come with a totally embedded sensors, and they're quite cheap compared to running the cables, maintaining them, and using labor to deploy them and commission it, connecting to a data acquisition system. A lot of effort is spent. So that this was an opportunity for us to demonstrate the wireless sensor network. The challenges, however, in a wireless, in a power plant is basically you have a lot of electromagnetic interference, right? You have motors there, you have generators. You're obviously going to have interference to these radios, to the radios in which these sensors are using to communicate. That's a huge challenge. Then, like I said, reliability, the accuracy of the data, and the data has to be available. So you cannot have, using these wireless sensors, you can't say that, okay, I lost communication to this sensor, I'm sorry, I don't have data for this particular time. That's a no for this kind of a setup. And apart from that, you have a lot of wireless technologies. Now, we're not talking about Wi-Fi, Bluetooth, there are a lot of other, right? You have Wi-Fi at home, you use a Wi-Fi router, you communicate through the internet using. So those are different set of technologies. But when you come to a sensor kind of, wireless sensor kind of a network, you would use standards that is basically the IEEE 802.15.4. And the protocols that come in this particular standard are what you see here, the ZigBee, the wireless HART, and the ISA. Now each of this, although they are all standards, protocols which are defined for low power, low speed, okay, low power in sense, they are typically powered by batteries, right? And batteries are like a 3.6 volt battery, which you would use just about few milliamps of current to, so you could, if you do a continuous drain from these sensors, you would do a continuous acquisition, the batteries would be drained out. But it's okay for this kind of a test because you're just going to run it for 3 days, and it would typically last this number of days. So the applications for all of these protocols are industrial sensor networks, and they would support distances up to 300 feet. So you basically would imagine, if I keep the sensor really far away, would it communicate? You could go up to 300 feet, which is what we have seen in our applications, primarily because since they're all distributed, if there is no line of sight to the other sensor, they would communicate using another route. So if there is a physical obstacle, if there are metals that are blocking one sensor to communicate to the base station, they would use another route. They would use a neighboring. You say, can you pass my data to the base station? I'm having trouble communicating to the base station directly. So that's the kind of the mesh topology network, you call it as. That's a kind of technology that these protocols would support, and that especially with the wireless HART. And the reason we chose this is because there are certain drawbacks. So when you compare, ZigBee was probably the first standard that probably came up, and then you had a lot of advantages in the wireless HART. You could actually jump between frequencies. You could hop between 16 different channels. You could actually sense if there is a clear channel before it communicates, whereas ZigBee, which is just using one particular channel to communicate, and this could actually stop the entire traffic. If all of these sensors are actually using one particular channel to communicate to the base station, at some point when you have interferences, when you have latency issues, this will actually block the entire network, right? So if you look at the test and the results that we got, so what you see here, right, as these are the kind of sensors that are used. So this is like a pressure sensor which was installed near the generator. So this is more like a pilot test for us. We wanted to understand, and we really wanted to, it's okay if it failed, right? But we wanted to know if it failed, if this is a kind of environment I gave the sensor, would it still communicate reliably? So we put it close to the generator. We put some of the sensors really high, they were really close to, if you see the heat recovery steam generators in a power plant, they're really tall. So that's the kind of the distances, the EMI that we chose, and we just used about 11 sensors, and I think one of them is a repeater. Repeater meaning it's just a radio. It will receive the data and just communicate to the base station. So when we install these sensors, we just took about 30 seconds. Sorry, what did I say? 30 minutes, not seconds. 30 minutes to actually complete installing the sensors, put the base station, and we started to get data. And mind you, these sensors were connected to the radio. They were wired between the radio and the sensor because these are precision sensors. We could not take chance on changing the sensor itself, but you have an alternate. Some of the wireless sensor nodes come integrated with a sensor, the radio. So they're all one full package. In this, we separated the radio, the communication from the sensing mechanism. So look at these results, right? So it was a short duration, just 3 days, but we had a good reliability. It was almost like 99% to 100%, which basically said that there is no loss of data. In whatever was your sampling frequency or sampling interval, the data came. Maybe they were, see if you could see the latencies, right? They were up and down. So at times when the nodes were not able to communicate, they used the other route and they still came back to the base station. And they all happened less than a second. So which is good, because we look at seconds data. We're not looking at very high frequency data and few milliseconds. So the stability, so although it varied from 60 to 70%, it took an alternate path. The data reliability was pretty good using the wireless HART topology protocol. Right? So in summary, basically what we wanted to tell the business was, look, you could use the wireless sensor. They're not bad for a short duration of test where you're not really bothered about batteries, because batteries is a huge concern. When you go wireless, the first thing people would ask is, how long is it going to last? What is your interval of, what is the sampling interval? Are these batteries good enough to last? And I want 20 years, and I don't want to be removing these sensors on and off and change the batteries. But this is good enough for a test which is just conducted 3 to 4 days. You have good latencies, you have less latencies, all the packets are received in time. So this was an example where we could demonstrate the wireless sensor network in industrial setting, and the business accepted because there was reduction in time as well as cost. So this was a good demonstration. I just wanted to give you an example. Please feel free to ask any questions. And maybe you want to take, okay, just let me know maybe. Use not 11 nodes, for example, how we could use 250. Right. Right. Correct. So you're saying how you could scale it up for a longer time. Okay. See, the batteries, if you know, right, they would all be rated. So rated for, say, 1 amp per hour or 900 milliamp hours. So you'll have to go by that. So for example, if I want to transmit a data at one instance, at a time when I transmit the data, there's a lot of stuff involved. So the receiver will wake up, transmit the data, communicate, go back to sleep. So even at sleep, it's consuming some power. So we'll have to optimize its life. So typically, when we use batteries for some of our local transportation applications, the requirement there is, if the sensor wakes up, gives me a data, just one single point, goes back to sleep, and it does so every 1 hour, I'm good for the next 10 years, provided that battery itself has a good shelf life. So if you're talking about power, so these are some stuff. So you'll have to actually, in the market, there are a lot of, it's a really competitive market, right? So there are some high energy density batteries, like the lithium thionyl chloride batteries, which are just the 3.6 volt, but they can really last about 10 to 20 years. So that's the kind of batteries that you want to use, provided you don't have a continuous data acquisition as your requirement. If it just wakes up 1 hour, it would do a good job for 10 years. And you could scale it up. These sensors can go up to 300, 400 sensors that would require. So each vendor would tell you, typically I've seen it going up to 300 nodes, 300 such nodes. But we've not really tested to that extent. But there are instances where people do use. Yes. Yeah. Alternative source of energy to going forward to empower all the wireless technologies possible. Absolutely, right? So I told you, I talked about the vibration energy harvesting, I talked about temperature, right? For example, say you put this node in some place where the environment is really harsh in terms of temperature, okay? First, the electronics of the temperature itself has to be secure, because we don't want it to degrade, right? If you look at the electronics, it's like 85 C is the maximum. But if you do a good thermal packaging, can last anywhere to 200 to 250 C. But that would add to the cost of your sensor. But coming back to the point that you asked, right, about the vibration, energy harvesting is the other alternate that people are thinking about. And there are products in the market where they say, okay, this is a device that will harvest the energy. It will take whatever vibration you have, provided you have good enough vibration, right? If you have a machine that's not vibrating so well, it's not going to give you enough power to store and power the sensor. But if there is good temperature, really high temperature, you could harvest the temperature. You could use heat as a source to store energy. And there's a mechanism involved for energy harvesting. But yes, there are ways in which you can. But what happens is, if there is, you need to have a continuous supply of vibration. You need to have a continuous supply of temperature to give that kind of. So it's completely based on how you design for that application. So it varies. But yes, there are ways. Yeah.
Say, for instance, you started off with 250 wireless sensors, and you need to add more, or one has become faulty, so you take it off and you add a new hardware. So do you have to sync it with the repeater or the radio?
Yeah.
So will you be syncing all of them?
No, typically what happens is, and provided they all come, they use the same technology, the same protocol, what you would do is, before you put each of these nodes, you need to program them.
Right.
There is an ID, like how you have a Mac ID, right? They would have an ID that's built internal. So you program it, give it a name, and say, okay, this is the interval of, this is what you would be measuring. You would probably use scaling factors if it is necessary. So you program it, introduce into the network. The best part about mesh topology networks is it is adaptable. So you introduce a sensor, it recognizes this is another member, is a new member. So it would do a routing information. So like a routing table like you have in your networks, right? So it would immediately say, okay, the way I communicate to the sensors, I can take this path, I can take this path, I can go directly. So that information is quickly built up. So yes, so you introduce the sensors, the nodes, and as long as they're all talking on the same technology, the same vendor, the same supplier primarily, they would immediately adapt. They can.
So I get that you are using the
Yeah.
sensors for performance monitoring of some mechanical parts.
Sorry, okay.
Is there any way I can monitor the sensor itself, like the battery is going down, and does it have a feedback loop on the sensor itself?
Yeah.
And built-in dashboards and kind of that, which will come free with these sensors.
Yeah. So for example, if I get your question correctly, you're saying if I put a battery there connected to the sensor, would I be able to understand how the battery is performing?
Or there is a backup battery facility and all that.
Or if there's a
Backup battery, like, two battery combined. Like, what I mean is, does it tell me the monitor sensor health itself?
Yeah, you can. See, when you say sensor health, one is it communicating on the communication side? Is a sensor physically giving you data? So what you would do is, just like how you monitor a patient, right? You would look at his temperature, the first feel. So in case of a sensor, a wireless sensor typically, if it is not communicating, the first thing you do is, does it have enough power? Does it have the power to transmit? So you would want to look at the voltage of the battery. So typically when the voltages are going low, right? So you know, okay, there's a battery is degrading. And there are other ways. If you look at battery monitoring, you look at voltage, current, capacity. There are a lot of models which would just look at just the battery health itself. But that's a different topic. But yeah, you could look at the battery and the communication. So say the battery. So the first thing is you need to have communication to the sensor. Once you have it, and if it is not, it is intermittently going down, then you say, okay, there's a problem with the battery. So you would do a fault diagnosis. So you would see what are the things that you want to look from the sensor. The first thing is communication, and you need to have, for the communication to be on, the radio has to be working correctly. For the radio to be working correctly, primarily your battery should be in good health. And internally, apart from all of this, if there is an issue, it could be a hardware issue, and that depends on the design, on how basically it is designed. So if I would look at from a flow sensor, right, I'm talking about remote. I'm not even talking about going there to look. If it's a remote monitoring you're talking about. But if you're talking about just go physically looking at it, you could You say, okay, it is not working, not communicating, you would just take off the radio, take off sensor and see, wire it to a data acquisition system and see if the sensor itself is giving you good data. But if it's just
Mostly I was
remote
talking
monitoring,
about remote only.
remote monitoring. Yeah, remote monitoring, the first thing you would do is look at if the battery is in good health, right? So the one way to do that is continuously trend how the voltage of this battery is. So sometimes in one of our applications, you've seen that the voltage kind of drops down, right? It drops. Sometimes, so if there's a, the voltage could still be steady, but you would not be getting enough data. So that means the battery itself has damage. There's a huge internal resistance which is not allowing the battery to pass the current. So that kind of stuff is there. Yes. Yeah. Yeah.
Yeah, so I wanted to know about how we are maintaining the data integrity when we say in the wireless network, right?
Mm-hmm.
Suppose we have mesh topology that we were
Correct.
talking about, and for some reason when I'm trying to pass a data in a particular sequence, say A, B, C, D, and A, B gets transmitted, and C, there is a obstruction that the sensor detects and passes through a different route. And D, when the D data comes in, it can again find the routing, a shorter route to the destination or the receiver, and it passes it to a different path
Root.
or route. How are we maintaining the data integrity? Are we going to add some checksum kind of thing along with the data, so that once it reaches the receiver, a checksum kind of a validation is done, and then finally whether the data is as it is supposed to receive, is it received? How are we actually trying to do this?
See, if you're talking about security, and I'm able to answer some portions of it. If you're talking about integrity of the data, some of these protocols, right, they come encrypted. So you could actually encrypt the data, and it's up to the receiver and the sender, okay, that we call it as the transmitter and the receiver, to synchronize this stuff, right? So you yourself don't do any additional effort because it's already programmed. The protocols, if you buy it, if you're developing a wireless sensor, then you have all the leisure to do all kind of it. But if you're buying it off the shelf, then you have to go with the vendor what he's saying. He will say, okay, these are the encryptions that are allowed. And if you encrypt it, you may add another extra overhead to this packet, right? So all this would happen, but so the transmitter and the receiver are already in sync. So irrespective of which packet it sends, right, it will all come to the receiver end, and it will ensure that unless it receives the entire packet, it will say, okay, the data is not, have not received the entire data set. It will try to re-communicate. So there will be, and sometimes there will be an acknowledgement that is sent back to the sender or the transmitter saying that, look, I've not received the data, please send it back again. So that is how the protocol communicates. And if you're a designer and if you're developing a wireless sensor, you have the leisure of programming it the way you want. I'm not sure if I've answered your question, but.
Hello everyone. So as Mahalakshmi told about sensor networks and the differentiation between sensor network and ad hoc network, did you guys get what is ad hoc network? Any clear, if you have not got clear understanding, I just want to say 2 minutes about ad hoc network. If you want to know about ad hoc network, please raise your hands. Yeah. So there are a larger audience who want to know what is ad hoc network. Other than the sensor network, the biggest difference between sensor network and ad hoc network is sensor networks are wired. They can have base stations. They can have infrastructure, internet backbone, all those things. But ad hoc networks are self-forming network. For example, I'm having this device. Suppose you are also having that particular device. There is no infrastructure available. There is no tower, there is no base stations. If this particular device is in the radio frequency of that device, it can form a network. It can create a network. It can send information from this device to that device. For example, all of you are having this particular device which is having radio frequency. That means this whole room can communicate to each other without any internet or infrastructure. So this is basically ad hoc network. if a person comes inside this room having this particular device, that person joins the network. This is self-forming network. If 2 or 3 people moves out of the room, that is deformation of the network. That is, nodes can freely move out or they can join the network. So you may ask now, what is the use of such a network? Basic application for this is, for example, there is human-induced some disaster or some natural calamities, tower is not there, infrastructure is not there, military application where building the base station is not safe. In such condition, all the militants can wear such devices, wearable devices, and they can form the network to communicate from source to destination, to pass on the message from one person to another. So these are the major applications. When I said ad hoc network, it is basically, if you browse the name as MANET, Mobile Ad Hoc Network, you will find abundant scholarly articles on MANET. So going through, is it clear for everyone? Yeah. So going to the presentation outline, I have already introduced about mobile ad hoc network. We'll go through problem statement, routing challenge, repair, approach, design, conclusion, recommendation. So as I said, wireless mobile ad hoc network consists of group of communicating hosts that form arbitrary network topology. So these form wireless links to each other, and they are used for military or other applications. So to determine feasible routes, each node should be available of resources. So when I say resources, what do you exactly mean? Bandwidth, delay, bit error rate, throughput. Is a device capable of all these things to successful transfer of the message? So basically we call this as quality of service. So when I say quality of service, it is the ability of the network to provide guaranteed service, guaranteed performance. Okay. First, the similarity between a sensor network and ad hoc nodes are, both are battery driven. If this particular device, which is battery driven, is drained out, this is dead. This is no more serving the purpose. Similarly, sensors are having much powerful batteries, but mobile devices, whatever is there, they will lose battery very soon. That is the only difference. Okay. So as I said, these are the nodes which has formed a self network. Now, each nodes are having its own battery capacity, which is shown in percentage. If you can see 78%, 82%, 84%, it may go to 0 and the node may die. That means that node is no more capable of providing the service. The quality of service constraints are delay, how long it will take to transfer the message, bit error rate, the error in the message to the total number of bits that is transferred, bandwidth, capacity of the communication channel to successfully transfer the bits. Route length will be usually measured in hops. Hops means, one hop means all the nodes which are one hop away from the source. Second hop, multiple hops. So if you move that, if the last hop is my destination, the message has to move from source to destination. This is how you define the route length. Energy, again battery driven. Route stability. Since I said nodes are free to move, you have to measure the stability. If nodes are continuously moving, is it possible to pass on the message? So you need to find the mobility of the network, then predict the future possibility of successful transfer of the message. Each node will have its own table containing these quality of service parameters. They will exchange the table with each other, saying that I'm having all these parameters. So this update is necessary for successful transmission of message. So when I say combinatorial stability, this is nothing but, just imagine you are updating the network and the nodes have moved out. What happens? The network update has not reached all the relevant nodes, right? So in this fault tolerance, what we are assuming is all the nodes, the network update will reach all the nodes before topology change. This is called combinatorially stable network. Is it clear? So fully distributed cluster-based routing. If I'm using flat structure of the network, it will lead to scalability problem. So what I will do is, I will group the nodes into clusters, different clusters. For example, I can take these as one cluster and the other 6 as another cluster, and I'll see, if you consider all this as nodes, I can form some 4 to 5 clusters out of this. So like this, if you form the cluster, you can manage clusters easily. That is the only use. Now suppose you say that now I have divided into clusters. How will communication happen if the source is in one cluster and the destination is in another cluster? So there is something called gateway node, which, if this is gateway node and this is in first cluster, it will pass on the message from first cluster to the adjacent cluster. So fully clustered based routing algorithm, what it uses is gateway node and clustering. Clustering is for managing purpose and gateway is to pass on the message to the adjacent cluster. Okay. So what is the disadvantage of this? Can I take questions later? Yeah, thanks. So what is the disadvantage of this? There is no effective way of if node fails, there is no effective way of handling the failure. For example, if this particular node has, if this is source and this is destination, and if this node has failed and it has to move from source to destination, if this has failed, there is no intelligence built in this routing protocol to pass on the message. So that is the only disadvantage. So there should be one solution, right? What happens if node fail? There can be two solutions. That is, you reroute. Again, start from the scratch. When you say reroute, again recomputation happens. That is costly, right? Now the second solution is multipathing. For the same destination, create multiple routes. That means again the disadvantage is multiple computation. That is also costly. So there should be a way to solve this problem. That's where my presentation comes, fault tolerance in wireless ad hoc network. How this fault tolerance will solve the problem is, if the one particular node fails, it will repair locally. It won't do rerouting, it won't do multipathing. The node is repaired locally. Okay, we'll see how it is done. So if you see here, in this particular case, the intermediate node has moved out of the radio range. So what it has to do now, in this particular condition, if you see a purple dot there, that is a node which is nearby to successor node and predecessor node. So what it will say is, I am able to link myself to the successor node as well as predecessor node. So what I will do is, it will say that I have this capability, so it will link itself to both the node. So that's how it will do. It will link itself to the successor and predecessor node. So this is how the intelligence is built such a way that the route is locally repaired rather than rerouting and multipathing. So to understand this particular concept, you should know few terms that is very general to understand. For example, yellow one is intermediate node. As I said, gateway node. This is gateway node, this is gateway node, and then there will be one more node which will act as potential gateway node. If suppose this gateway node fails, the potential gateway node will act as the next gateway node. Defunct node is nothing but the node which has failed. Maybe it has moved out or it has died out of battery. Okay. So one more intelligence has been added here, that is called cluster head. Cluster head technique is added. That is, if I am in one cluster, based on certain weight, I will be elected as cluster head. And my responsibility is to take care of all the nodes which are in my cluster. So what is the responsibility of that cluster head? Take all the data from the nodes in that particular cluster. If there is root failure, repair. Repair is the task done by cluster head. Now, going to the repair algorithm, I just want to say few terms here for you to get the flow of the algorithm. CH of V is cluster head. That is, V is cluster head. Cluster of V is V's cluster. V's cluster. Connects U means U is supporting the connection. Means the intermediate node which was supporting the connection. Connects params is the variables stored in a table by the cluster head. All the quality of service parameter which is required is stored in the table for that particular path. For this particular path, what is the quality of service requirement? That is stored by cluster head. And that is here. Okay. NT and AT are quality of service table and resources table of that particular node. Okay. So now we'll start with the algorithm. If you see here, node failure of V. Node V has been failed. What happens? Now it's the responsibility of cluster head to take care of the failure. So if V is cluster head, CH of V is cluster head, and that whatever node failed, U belongs to that particular cluster head. Are you following? Now, what should be the new cluster? The node has been died. The node U has been died. That means it should be removed from the cluster. So that is what happening. Then cluster V is equal to cluster V minus node U. Next comes, if connects U is equal to true, whatever the node failed, that is node U, if it was supporting the connection. Yes, if it was supporting the connection, there should be some neighboring node which should take play the role of repairing. So what you have to do is, you should search in the cluster. The cluster head will search in the cluster some random node Z, which is having all the resources Z.nt and Z.at greater than quality of service table which cluster head is holding. It should compare. If I'm ready to repair, I should compare whether I have resources to satisfy this. So I will compare myself to the quality of service table for that particular path. If it is having resources, that is greater than equal to comparison. When it happens, if it is true, a new path will be calculated, and whichever node leads to that particular path, it will send a message saying that repair this particular path. So here you will send a message, repair this connection. Else means that particular node do not have resources to satisfy the repair. So what it does? It will send message that straightforward, no, I'm sorry, I can't repair the node. Now, I said the intermediate node, whatever was there, that has failed. Now we'll take one more case where whichever node has failed is cluster head itself. What will happen? If cluster head is failed, you should do two tasks. You should find next cluster head, and whoever is elected as next cluster head should take the responsibility of repairing the task. So again, else if cluster head is equal to you, that is whichever node which has failed is you, then you have to find new cluster head. How are you finding new cluster head? By weightage. Comparison of the weightage, it will be always greater than 0. And it will be comparison of quality of service parameters only. Now, if V is elected, if V is having a highest weight, what it will do? It will send message to everyone, CH, capital letter CH of V, to everyone saying that I am next cluster head. I can take the responsibility. So, what is the responsibility it takes? Again, it will calculate the resources of any node in one hop away is able to support this failure. That particular node will be again taken one hop away. Again, it will check with the quality of service. Again, same thing happens. If it is having greater resources, it will repair. Else, it will send message saying that it can't. Now, we will again take one more condition. What if previously we said that I am having highest weight? What if V is not having highest weight? That means somebody else in the network is having highest weight. So what V has to do? It has to wait T units of time, because it is expecting I am not having highest weight. That means somebody else is having highest weight. So I should wait T units of time to receive the message from node Y saying that node Y is cluster head. When it receives message from the node Y, it will join node Y's network, and it will update its quality of service parameter to who is next head? Y. So it will send its quality of service parameter to Y. Are you following? Now I said repair algorithm. It will send repair. What happens in repair? If I am receiving a repair message, if I am a node, that is I am a potential node to repair, what I have to do? First I have to check who has sent me the message. Generally cluster head has sent me message giving a duty that repair this path. So what I will do? I will first check whoever has sent me the message whether he is cluster head. So it will check if cluster head is equal to cluster head. Then when it gets a confirmation that cluster heads had sent the message, it will check its own resources with the quality of service table. It will check its own resources with the quality of service table. If it is true, it will send message to the cluster head saying that I can repair. Now it will I can repair. Sorry, if it is less, if it is not having sufficient resources, it will send message saying that repair failure. Else there is no problem for him to repair the path. So what it will do? It will send the message saying that link repaired. So I hope this algorithm is quite clear for you. Since time is running, so I had to run fast. To conclude, as I said, uh, whatever the algorithm is designed is to locally heal the link. Now, the disadvantage was rerouting and multipathing. So considering rerouting and multipathing, the repair method is less computational cost, and it has the intelligence to locally repair the path. What is the recommendation? So recommendation for the future study will be, what if I make cluster size small? What if I make frequency more? What if I make stability? What if I increase number of cluster heads in a cluster? If doing all these changes, will it increase the performance? Performance as in the performance in terms of successful transfer of message from source to destination. So that will be a recommendation for the future study. It may decrease or it may increase, that is just a recommendation. So any questions?
So in our as you are saying, these networks are built on top of mobile phones. The only adapters I have today is a Bluetooth and a wireless adapter, right? So is this which adapter does this leverage?
It's not necessarily whatever mobiles we are using. There are many devices outside which is designed particularly for military applications. The devices designed for military applications and rescue operation. You can use your PDAs, you can use your Palm Pilot, any devices which can...
I saw in one of the slides you said we can build home networks also.
Yeah, you can build home network also.
So if my family has like couple of mobile phones, what else I should have on my phone to enable such network?
You can just switch on the whatever, which device you are having.
Like iPhone, HTC. And
Yeah, those all are work with Bluetooth only. So you have to enable Bluetooth to transfer. That's all.
Similar to Bluetooth network only.
Yeah, it's similar, but I won't say exactly, because the devices which are used in military application is having more capacity, more radio frequency, more data rate compared to the devices which we hold now.
Yeah, I was just wondering because some phones don't have Bluetooth. I was wondering if I can make such network.
Yeah, the phone which is not having Bluetooth is of no use,
Oh,
if for the home network.
So one other question is, do the node check its quality parameters and promote itself to a gateway, or someone needs to nominate it as a gateway or a cluster head?
So quality of service parameter is set to one level by the algorithm. So you should have this much bandwidth, it should have this much, you should not tolerate this much delay. All has been set by the algorithm.
So it is a self-promotion kind of thing. Any node.
Yes, each node will have the intelligence.
Just out of curiosity, how do you identify the nodes, or have an ID for the clusters for that matter? Like,
Sorry?
you should have like IDs for the nodes also.
Yeah, each device have its own unique ID. So for example, this won't be applicable for the military application, but if you open your Bluetooth device, definitely the surrounding devices will have its own unique ID, using which you recognize and send the message. Similarly, there will be one unique ID which this device will be knowing to send to the destination.
And how do you identify the particular clusters that the network is making?
Sorry?
How do you identify the clusters that the network is making? So within a network you have particular clusters. So
See, when I say cluster, it is logical arrangement. It is not physical.
Okay. And one more question. So the range of the nodes would be the range of the, so it's basically radio communication, right?
Yeah.
So the range of the nodes would be within the radio range.
Yeah, yes. Whichever node in the radio range, they only can communicate.
Okay. All right. Thank you.
she's having question.
So as you are saying, for with this fault tolerance thing, right, rerouting don't have to do, right? But if you see, right, the node which is faulty, that node has to do the rerouting or recomputation again, right?
You mean source itself
Yeah.
is
Yeah.
faulty?
Yeah.
Then you cannot do anything. It is straightforward. Source itself has gone, moved out. You cannot do anything.
So in that case, it has to be done.
Yes.
Thank you.
Basically, this will be best effort service. Since nodes are in continuous mobility, you can't guarantee the message you're sending will reach. That's why I told combinatorially stable network we are considering.
Is it
Necessary to have cluster head, but to increase the efficiency, the cluster head feature has been added, that's all.
No, and source and destination, so can we have like a group of like different nodes, and in a group so communication can go, it's a two-way street sort of system?
Yes, you can have one way also, two way also.
Within multiple, simultaneously multiple.
Yes, simultaneously two or more source can pass on the message to the destination using the same path.
With multiple destinations, multiple sources.
Yes, it is possible. I guess thanks for your active participation.